The idea that an alien civilization might be observing us from afar has always intrigued scientists and philosophers alike. If such a civilization existed and was genuinely interested in monitoring the evolution of life in the inner solar system, it would be unlikely that they would simply pass through once and never return. A truly advanced species would plan with precision, patience, and purpose. Rather than conducting a single flyby mission, they would probably station a large mothership somewhere within the solar system, a strategic base of operations capable of deploying multiple smaller probes. These mini-probes could be sent into stable, bound orbits around the Sun, designed to monitor planetary environments and technological developments over centuries or even millennia. Launching these probes could be achieved with clever orbital mechanics. By ejecting them at velocities opposite to the direction of the mothership's motion, their net speed relative to the Sun would drop below the solar escape velocity, ensuring they remain gravitationally bound to the system. Such a deployment would create a persistent network of observational devices quietly circling the inner planets, each one functioning autonomously while sending data back to its parent craft or to interstellar space. The very notion that such probes could exist is both fascinating and unsettling. Unlike natural celestial bodies, asteroids, comets, or meteoroids, these probes would exhibit subtle but measurable deviations in their trajectories. Their movements might not be governed solely by gravity. Rather, they could demonstrate non-gravitational accelerations due to internal propulsion, radiation pressure control, or active navigation systems. However, unlike comets, they would show no visible outgassing, no tail, and no sublimation effects. To even the most sophisticated telescopes, they would appear as tiny, unresolved points of light, indistinguishable from inert rocks drifting through space. The problem of detecting such objects lies in their size and distance. Even our largest human-made spacecraft, such as the 10-meter-long probes currently exploring the outer planets, would appear impossibly small from the distance of the Earth-Sun separation. The angular size of a 10-meter object at 1 astronomical unit is on the order of 10 microarcsecons, a scale far beyond the resolving power of even the most advanced observatories. The James Webb Space Telescope, with its massive mirror and infrared sensitivity, would see such a probe as nothing more than a single pixel of light. Even the Event Horizon Telescope, which effectively combines radio dishes across the entire planet to create an Earth-sized aperture, could not resolve such an object, even if it emitted millimeter-wavelength radiation from its ends. To us, the probe would be an unresolved, point-like anomaly, an object we could track but never visually discern. This brings us to a deeper question. How would astronomers classify an object that appears as a point of light, shows no cometary activity, yet displays non-gravitational acceleration? Our scientific tendency is to label phenomena in terms of known categories. When something behaves strangely, we often fit it into the nearest familiar box, rather than creating an entirely new one. In 2024, a research paper reported on 2 populations of 14 so-called dark comets near Earth. These objects showed no visible cometary activity, no tails, no gas emission, but they nevertheless exhibited subtle accelerations inconsistent with pure gravitational motion. The authors labeled them dark comets precisely because of this mystery. They behaved like comets dynamically, but looked like inert asteroids. However, this labeling might be misleading if the objects were, in fact, technological in nature. If we imagine that some of these dark comets were actually artificial probes, autonomous devices built by an alien intelligence, the term becomes almost absurd. Calling a technological probe a dark comet is like calling an elephant a stripeless zebra. The analogy captures the human bias inherent in scientific interpretation. We name and classify based on what we already know. Cometary scientists, trained to study icy bodies that sublimate under solar radiation, naturally interpret anomalies through that lens. But as Shakespeare once observed, a rose by any other name would smell as sweet. Likewise, an alien probe, even if mislabeled as a comet, would remain just as intriguing and just as profound in its implications. The story does not end with academic semantics. Misclassification has real consequences in astronomy. On January 2, 2025, the Minor Planet Center, an authoritative body that tracks all known asteroids and comets, announced the discovery of a new near-Earth asteroid. Within just 24 hours, the announcement was retracted. Astronomers realized that the object's orbit matched that of the Tesla Roadster, a car launched into space by SpaceX in February 2018 as part of the Falcon Heavy's maiden flight. Without contextual knowledge that a car had been launched on that trajectory, the object appeared indistinguishable from an asteroid. To automated tracking systems and optical surveys, it was simply another rocky body reflecting sunlight. The recognition that it was, in fact, a car, a manufactured machine, required human context and technological history. If such confusion can occur with an object we ourselves launched, how easily might we misidentify a truly alien artifact? This example highlights the limitations of human perception and the frameworks of science. Observational astronomy depends on pattern recognition and statistical inference. When a new object is detected, its behavior, brightness, reflectivity, orbit, is compared to established models of natural bodies. Only if it deviates strongly from those models do we begin to question our assumptions. Yet, even then, scientists hesitate to invoke technological explanations. This reluctance stems not from ignorance, but from methodological caution. The scientific method demands that extraordinary claims require extraordinary evidence. Declaring an object artificial without direct proof would seem reckless. However, the boundary between skepticism and blindness is thin. There is a risk that excessive adherence to conventional models may cause us to overlook phenomena that truly defy natural explanation. Consider the famous interstellar object Oumuamua, discovered in 2017. It entered the solar system from outside, exhibited non-gravitational acceleration, and showed no signs of a cometary tail. Its shape, brightness variation, and trajectory all puzzled astronomers. Some proposed that it was an unusually thin, tumbling shard of rock or ice. Others, including Harvard astrophysicist Avi Loeb, suggested that it might be artificial, a light sail propelled by radiation pressure. The debate revealed a deep divide in scientific culture, one side demanding conventional explanations, the other urging openness to unprecedented possibilities. The Dark Comet controversy is an echo of that same divide. It exposes our cognitive bias. When faced with an anomaly, we would rather stretch existing categories than invent new ones that challenge our worldview. If alien probes truly exist in our solar system, they might be small, silent, and nearly invisible. They would not announce themselves with radio beacons or visible emissions. Instead, they would operate stealthily, optimizing their detection limits to avoid interference. Such probes might harvest solar energy, collect data about planetary atmospheres and civilizations, and transmit information using narrow, hard-to-detect communication beams. They might even use natural-looking orbits to disguise themselves among asteroids and comets. To us, they would appear as harmless dots of light, cataloged, observed, and forgotten. One could imagine an alien mothership positioned beyond the orbit of Mars, perhaps within the asteroid belt or near the Lagrange points where gravitational forces balance. From there, it could periodically dispatch new mini-probes or recalibrate existing ones. These probes, each no larger than a small spacecraft, might possess the ability to self-repair, replicate, or even evolve. Over millions of years, such a network could maintain continuous surveillance of the solar system, monitoring the rise and fall of civilizations on planets like Earth. The goal might not be invasion or contact, but observation, an interstellar version of a wildlife camera studying the natural evolution of intelligence. The implications of such a scenario are profound. It challenges our sense of cosmic isolation and scientific objectivity. If we are indeed being watched, then our telescopes, space missions, and even our acts of discovery are themselves being observed. The very moment we label a dark comet, we might be labeling someone else's creation. It raises philosophical questions about humility and perspective. How many times in history have humans mistaken technology for nature, or nature for technology? How often have our scientific classifications limited our imagination instead of expanding it? In the end, what we call an object does not change what it is. A technological probe misidentified as a dark comet still represents the same mystery, a foreign intelligence quietly embedded in our cosmic neighborhood. The act of naming reveals more about us than about the universe. It reflects our tendency to interpret reality through human experience, even when faced with phenomena that transcend it. Just as ancient astronomers once mistook planets for wandering stars, modern scientists may be mistaking alien artifacts for inert space debris. The universe, vast and ancient, is unlikely to revolve solely around our comprehension. If other beings have reached the stars before us, their machines might already be here, unnoticed, unacknowledged, and mislabeled. Perhaps one day, as our instruments grow more sensitive and our minds more open, we will re-examine the so-called dark comets and recognize them for what they truly are. Until then, they will remain silent witnesses to our cosmic adolescence, proof not only of what we see in the sky, but of how we choose to see it. For as Shakespeare once said, a rose by any other name would smell as sweet, and an alien probe by the name of a dark comet would appear just as extraordinary.